So we've got two speakers tonight showcasing quite different innovations that we think will be useful and interesting to people who want to make their homes more energy efficient. So first of all, we're going to be hearing from James Hoople from Mixergy. Mixergy have developed a smart hot water tank, and it has the intention of helping you optimize the storage and the usage and the creation of hot water in your home. So that's an interesting technology, which I think many of us will be able to find an application for. And then secondly, we have Leigh Fairbrother from Qbot, and they offer an interesting solution to the difficult problem of how to insulate a suspended floor. And they do that with a minimum of disruption by using robots. So without further ado, if I could introduce you to James Hoople. He's the Business Development Manager for Mixergy. And James, if you'd like to take us through your slides, that would be a great place to start. Thanks.
So just a bit about our beginning. So the company was founded in 2014. We're an Oxford University clean tech spin-out. After a couple of years of innovation, of R&D, the product was launched in 2017. Our headquarters are in Ensham in Oxfordshire. So we're the market leader in the world in connected and smart hot water tank innovation, okay, with a real mission to decarbonise the home and wider energy networks. So in terms of our growth, we've got more than 2,500 Mixergy tanks installed in UK homes through a network of 150 plus accredited installation partners. We also work with British Gas, who invested in us twice now. So that's the UK's largest heating installation channel. More than 2,500 tanks have been specified on new build and social housing projects. And we're delivering more than 2 megawatt demand side response. Don't worry if you don't know what that is. I'm going to touch on that briefly at the beginning of these slides. And this is basically a service to National Grid through a decentralized digital network of water tanks. So we've raised over £5 million to date to support our growth. So, we're addressing this challenge of the decarbonisation of heat. So there's an urgent need to phase out fossil fuels. We all know that, whether gas boilers are going to be phased out, certainly new builds in 2025. And then HMOs, social landlords all have the same issue in terms of raising their EPCs by 2030, by 2040, by significant amounts. And we've got to manage this greater renewable energy capacity coming online. So the grid is changing all the time with the advent of more and more renewable coming online. That poses many problems in itself. There's a need to protect households from fuel poverty, whilst providing the guaranteed comfort and best control that they're used to. So we need cost-effective, future-proof standards for new homes, whilst also offering an effective solution for existing homes. And then all the time, with all these new, the burgeoning sector of new smart technologies that are increasing in the UK marketplace at the moment, there's a need to grow the installer base, with the skills to actually, deploy these technologies. And one of the sort of stronger veins at the moment is the need to address the grid constraints due to EVs and heat electrification. So all of these things we're addressing as a company. So the challenges with existing hot water cylinders is that they heat all or nothing. So nothing's really changed with hot water cylinders for the last, say, 50 years, apart from sort of greater insulation. So they heat all or nothing. That's irrespective of what you need. This means high heat losses. There's no visibility of state of charge. So we refer to the hot water inside the cylinder as a state of charge. There's no way of using electricity instead of gas when there are high winds or lots of solar. And there's chronic underpasteurization. If you see the bottom graphic there of the two cylinders, you can see the sort of blue domed bottom. And the way the convection currents happen within the cylinder, you can't drive heat down underneath in immersion. So that's where you're going to get your Legionella concerns, right in the base of the cylinder. And they have primitive controls, so you can turn them off and on a certain time of day and set them to a certain temperature, and that's about it. So we're fast, economical, and smart. So we can heat water up to 5 times faster. That's a picture there on the left-hand side of our smart new range of cylinders. That's what they all look like. They're economical, so they only heat what will be used. There's a return on investment of around about anywhere between 5 to 8 years, depending on what you go for, size-wise, and what you connect it to. And there's a 25-year product to lifespan guarantee on the cylinder. And they're smart. So we provide data-driven insights into household requirements continuously, and we can monitor cylinders throughout their life as well. So I'm just going to play a short video now that gives you a lovely overriding sort of snapshot of our technology. Just give me a yay that you can hear the audio okay.
A Mixergy tank is a smart, flexible and connected hot water cylinder. The Mixergy cylinder only heats what you need rather than all or nothing, allowing maximum energy efficiency and rapid reheat times. The Mixergy tank is as easy as any hot water cylinder on the market to install and comes with an extended 25-year warranty for peace of mind. The Mixergy tank connects easily to your phone, so you can see how much hot water is inside at any time, whilst allowing maximum control. The Mixergy cylinder enhances the boiler performance and can reduce gas usage by as much as 20%. The Mixergy cylinder is smart tariff ready, allowing you to take advantage of low cost and low carbon energy in the future. The Mixergy tank is designed to seamlessly change between energy sources during its working life. This gives users a system that is future-proofed for our zero-carbon future. The cylinder can swap between gas, electric, solar PV, and even be upgraded to heat pumps in the future without need for replacement. The Mixergy tank is a cloud-connected IoT device. This allows it to connect to the internet for app control, as well as enabling integration with other smart IoT devices, such as your smart speaker. Control your Mixergy tank with Alexa voice assistant, or control your cylinder via the Mixergy app. There is even a cylinder-mounted controller allowing you to boost at the tank. Heat what you need and save energy. Lower carbon, save money and save time.
There we go. Hopefully you all feel a bit more excited about hot water cylinders. Let's move on. So, what's inside? How does it differ from a standard cylinder? So, I'll just race through this. We've got a standard, cylindrical object. Effectively, we've got an embedded full height temperature sensor. So, there's a full length temperature sensor that runs from top to bottom in the cylinder. So we can, analyze and make adjustments depending on what the heat and the temperature is throughout the cylinder. There's a top mounted coil in indirect mode. They all come with a top immersion for grid electric, or to link to solar PV systems. There's a smart control unit on the side, which is a side-mounted control unit. That contains our, the brains of the operation, which is controlling the smart scheduling and linking to smart tariffs, etc. There's a variable speed pump on the bottom right-hand side there. And there's an inlet diffuser at the bottom, which is one of 7 patents inside our cylinder. So all of these link to, the real working and how our cylinder actually works. So if I just go on to that now, I can down. There we go. So power is sent to the top immersion coil via the boiler and begins to heat the water above it. So what we're doing is, as the water enters the tank, it doesn't just rush in like it would do on a standard cylinder to replenish whatever you've taken from the top. It hits a plate diffuser at the bottom, which spreads it out very evenly. That's then sucked up via that variable speed pump, which I mentioned in the previous slide. The cold water is taken to the top, to the thing that looks a bit like a cowbell on the side there. And that is basically diffusing and spraying the water out directly above the top immersion. This water then begins to heat. So what we're doing is we're manipulating a process called stratification, whereby hot water will simply sit above cold water quite happily. So the whole the most important thing about our tank is the way that the water is handled within the tank. We're not causing any turbulence between the hot and cold, so they don't mix, okay? And depending on what the schedule says, if we need more water, then the variable speed pump will keep injecting water into the top of the tank as it's passing through that piece of pipe work, still not, touching or mixing that, the hot and the cold, and injecting more, driving down that hot water layer from the top of the tank to the bottom. So, the pros of doing this is we're only heating what you need. We can heat anything between 10 and 100% of that cylinder. In increments of 1%, we can be very accurate about that. So we're halving heat losses on average. And what we mean by that is, across the whole range of cylinders, we know what the average state of charge is. And most people are hovering around about 55%. Okay, so if you're holding only half a tank of hot water at any given time, as opposed to a whole tank, we're halving our heat losses. There's 30% more usable hot water due to replenishing cold water, not diluting what has already been heated, and much faster reheat speeds. Most people would drain off maybe 10, 20, 30% of a cylinder in terms of having a quick shower. Okay, so why are we heating the whole cylinder when we only need 30%? So this 30% more hot water from the same volume cylinder, how do we achieve that? I mean, it's all over our marketing. And the way we do it is by this very precise handling of the water as it enters the tank. So what these graphics represent, the top is a Mixergy cylinder and the bottom is conventional, and they represent drawing off 30% of the cylinder's volume. So we take the conventional cylinder first. If we draw off 30% from the top, in rushes the coal to replenish, and it just shoots into the cylinder and dilutes 60% of the cylinder. Okay, this is what you just spent money heating, and then you're diluting it again. With a Mixergy cylinder, you draw off 30% from the top. In rushes the coal at the bottom, but it doesn't rush in. It hits a plate diffuser. It's controlled, it's handled, it's passed to the top of the tank, injected in precisely as a fine mist above either the top coil or the immersion, and then we're driving that hot water layer down. So 60% still remains, and 30% is at the bottom. And the thermocline between the hot and cold is basically no more than about 10% of the cylinder. So that's how crisp we can get the difference between the hot and cold. So the impact on this is you can actually install a cylinder 30% smaller and have no, you don't really see the difference in performance. Or you can just have the additional 30% capacity in reserve. So, we speak to lots of young families with young kids who are growing up. Why not install just a slightly bigger cylinder now? It will cost you no more to run it. I could have, living on my own, a 300-litre cylinder, and I could just increase the percentage that I heat over time. As my family grows, I can just increase the percentage. So there's two ways of looking at it. So we're flexible, where we can work with, gas boiler, direct electric, heating, a heat pump, solar thermal, solar PV. The Mixergy tank helps you save energy, reduce your bills, and cut carbon emissions. So what we've done is we've, facilitated, the change to any foreseeable energy sources that you might want to heat your water with without having to rip out your cylinder in the future. Okay. So direct electric systems, this is what we're seeing more and more of. People want to get off burning fossil fuels, and we can lower bills by up to 40%. That's around about £100 per annum on a hot water bill, versus your conventional electric cylinder. We're much faster recovery. So we get to a usable temperature, usable volume, anywhere we say between around about 10 to 40 or 50%, 5 times quicker, because we're not asking the 3 kilowatt immersion to heat the entire tank. We're heating what you need. The smaller tank size, we deliver up to 30% more usable hot water. Optimizes solar energy self-consumption through PV or thermal, which I'll go into in a bit more detail shortly. It's a sweet spot for the system. We're heat pump ready. The whole range of cylinders come heat pump ready now, so you can connect now or in the future. And they're smart tariff ready. Again, you can connect now or in the future. So the Energy Savings Trust has now verified the tank can save you 12%. So if you, in terms of gas consumption, so if you're still using gas to heat your water, then fitting a Mixergy cylinder typically reduces the amount of gas used to provide hot water by 12%. If a boiler is short cycling regularly, which does occur quite happily in most scenarios with boiler cylinder link up, fitting a Mixergy cylinder can help to eradicate this, leading to total hot water savings of up to 20%. So EST tests also showed that the Mixergy tank is the most efficient cylinder tested in every department, outperforming other top branded cylinders. So controls wise, how do we control all this smart technology? And the important thing to note at this point is it all seems fairly complex, but it's really not. The cylinders can be set up to, you can agree on a completely manual schedule if you feel comfortable in doing that, setting different temperatures for different days, different heat sources. You can do whatever you like. It's in full manual mode. Or you can have full automated mode, where the cylinder will take care of your every hot water need and everything in between those two polarized views, really. So on the left-hand side, you can see the control unit. So this is a manual, 3D printed manual gauge. It's on the side of every cylinder. There's 10 LED lights on the front of that. Each LED light represents 10% of the cylinder. So on that particular example, you can see 4 red lights at the bottom. I know I've got 40% in my tank, okay? And you can manually boost this to override anything in your smart schedule. The second icon there, that is showing you the homepage of the smart app. That's going to be the main way you're going to control your cylinder. And I will delve into the app shortly. The third is basically the Mixergy.io platform. So this is what we see if anyone was to ring us up with an issue with a tank. For example, where you've got tank MX000255, I can then open that up on my laptop, or a building manager can do that, or an FM company. We've installed in extra care facilities where we've got 50 cylinders, in old people's home, and the building manager can look at all 50 and see how much energy they're using, see what temperatures they've been set at, see when the cleansing cycles were, and we can determine exactly what's happening there. If there's any issues, then you'll quickly ascertain what's happening and let you know, and to actually tweak things our end as well, so all over the phone. And then on Finally, we've got the voice activation. So if Google Assistant and Amazon Alexa are your thing, then we cater for that as well. So you can actually talk to your cylinder now. Fantastic. So this is the app. So on the left-hand side, that's the home page. Just gives you the hot water temperature, the cold temperature, and how much you've got of each. The second is your schedule. So if you want to put it in a manual schedule, this is how you'll do it. So you'll see at the top there, heat to 60%, then maintain between 20 and 30%. So this is a regular setting for our customers where you can ask your cylinder not to drop below a certain level, so you never run out of hot water, okay? And then you can just repeat those settings, Monday through Sunday, or set different ones if you so wish. Just gives you an example of your hot water level graph that you can ascertain using the app. Energy used, same thing here. You can see how much energy you're using over time. You can drill down into any particular day, any particular moment. You can even understand how much a certain shower cost you at a certain time of day, if you so wish. Holiday mode, so you can put it in holiday mode. Very, very simple explanation on that. Just put your dates in and it won't draw any power. Carbon intensity. Now, this is a really cool one. So this is basically forecasting the carbon intensity of the national grid. So, what energy is coming online, how much nuclear, how much coal are we burning, how much wind energy, how much solar PV is online at any given moment. So it's not just about energy savings and saving you money. If you want to employ the services of the Mixergy Hero scheme on the app, then it incorporates this. So what the machine learning algorithm is going to be doing is going to be looking at how much green energy is available on the grid, and it's going to be trying to use that to heat your water as opposed to sort of more brown sources of fuel. Again, you can just see the power consumption there over time. So delve into any point in time and it will tell you the power consumption. Default heat source, so you can change your heat sources at any time you like. For example, we've got heat pump linked cylinders. With heat pump cylinders, you don't volumetrically heat them, you have to heat the whole thing. But you might want to just heat 10% of your tank. So what you can do is go into this screen. Your default heat source will be heat pump here, for example. You can just put the press the drop down there, switch to grid electric, and then heat 10–20%. So you're not asking your heat pump to fire up, get up to loop temperature, and then heat your entire contents. If you just want a quick shower, stick it in direct mode, heat 10% of the tank. So you can flick between heat sources at will there. And finally, just your tank settings there. So it's the main page of settings. It gives you a target temperature, so you can reset that. You can ask it to maintain the target temperature. And then your heat pump temperature there if you've got a heat pump. Enable grid assistance. This is the DSR facility on the tanks, which I'll delve into at the end of the slides. And then your automatic schedule control. So standard economy off. This is where you ask it to, you can actually predict how much hot water you need, or you can set it manually. And again, I'm going to delve into that shortly. So machine learning. So this is a really one of the sort of key aspects of the technology, and what the machine learning algorithm will do if you employ its services. This is, as I said on the last slide there in the settings, on the option, you set it to economy mode, and what it's going to be doing is going to be analysing how you use hot water in your property. So over the course of about 2 or 3 weeks, it's going to be splitting up your day into 48 lots of half an hour, and ascertaining exactly what water you use and when. So then it's going to start predicting what you need as and when. Okay, so what it's trying to do is cut down on the heating of your water as much as possible. So test demonstrate the Mixergy tanks using machine learning capability can provide additional savings of around about £55 a year, a 40% reduction on water heating compared to the same tank operating with user controls only. The only thing with this is, obviously, because it's trying to predict what you need, you have to keep in the back of your minds that, perhaps you can't just run that impromptu bath in the afternoon without manually boosting it. What it's doing is it's trying to save you money and getting you to where you need for the cheapest possible cost. So renewable connection, a large part of what we're doing at the moment is connecting to solar PV. So this looks fairly complex, but it's very, very simple. If you want to connect to PV system, absolutely you can. They all come PV ready. So all you need to do is get yourself a third-party PV diverter control unit, something like an iBoost or a MyEnergy that's shown in the picture here, and that just basically connects to the top immersion, which is a dual-fed immersion. Okay, and that's it. So any surplus energy from your PV system will be diverted to the Mixergy cylinder, making a valid contribution at all times. We also have a fully embedded solar PV option. So this is what we designed for developers. And anybody can have this. We say it's for developers simply because there's a bit of extra infrastructure to consider. So this negates the need for that third-party solar PV controller, and they can range in cost between anything from about sort of 350 to 600, depending on what what option you want to go with. And this comes with the PV diverter control unit already installed on the side of the cylinder. So all the installer has to do is link that up via an Ethernet cable to your router, and away you go. All your PV power will come into our cylinder. Okay. So what's the main advantage?
James, could I just ask, could we just want to make sure we've got enough time for Leigh as well? If
sure.
you could bring it to a point where we could ask questions, that would be great. And then obviously we can cover more, after
Yeah, absolutely. Yeah. So if I just run over this point, it's a really interesting one. So just in terms of, why are we more effective than a standard cylinder? On the left there, you can see that, you have to heat the whole cylinder for your 6 o'clock morning shower event. You draw off 40%, and that is the maximum amount of energy you can put back in your cylinder from your PV system. With the Mixergy cylinder on the right there, because the machine learning will actually gauge how much you need at 6 o'clock in the morning, we haven't had to heat the whole thing. We've just had to heat to 20%, and we've basically given almost a whole tank of cold water to set far more solar PV. So we get around about 40% extra solar PV power coming into your cylinder. So they're all heat pump ready. I've touched on that. Smart tariff connections. This is really, really interesting. It's something that's coming more into the fray now. Agile octopus rates, we can track those rates, and we can heat water using the really cheap rates in the early hours of the morning. So the machine learning will tap in and out of those cheap rates and make sure you get to where you need for the morning shower event or bath event in the sort of least amount of money spent as possible, basically. And just to finish off, just a few people working with, so Sierra Homes, Carla Homes, Melius Homes, just to throw a few names out there. But yeah, I'll be sort of happy to take any questions from the floor.
James, thank you very much for that. Fascinating stuff, actually. Paul, do you want to invite the questions in?
Yeah, we have a few questions. Tom, I think yours was first. If you'd like to unmute and ask your question.
So thanks, James. This looks amazing. But would a normal plumber know how to install a Mixergy?
Yes, absolutely. I mean, they would probably go a bit white in the face at first, and then they realise that there's very little difference between ours and a standard installation. In fact, electrically and plumbing wise, it's identical. The only difference is the Wi-Fi connection aspect of the tank, and that is simply an EOP switch, which we provide in the box. You plug it into a 3-pin socket and run an Ethernet between that and your router. That's the only difference between ours and the standard cylinder. All of the clever stuff happens behind the curtain, as it were.
Okay, and we've got a question from Leigh, a very specific question. Leigh, if you'd like to ask your question.
Uh-oh.
I'm just interested to know if there's any intention or possibility of introducing a horizontal tank, or would it just not work with the technology?
Yeah, I mean, we do get asked this quite often in small loft spaces, and just with the fact that we're driving that hot water layer from the top down to the bottom of the tank, it wouldn't work in terms of stratifying a tank correctly in a horizontal form. So yeah, at the moment we're only doing vertical. We do slim lines and standard diameter tanks. That's all we offer in terms of the actual shape of the cylinder.
Thanks.
And the next question comes from Anne, if you'd like to unmute.
Hi, James. It's a kind of related question. I mean, how squat can they be? I'm thinking of the cupboard underneath my combi boiler. It's about 1.1 meters high. Could I fit one of those in to sort of transition towards getting towards a heat pump sometime later?
You certainly can, yeah. So a 120 litre would fit perfectly in that area. Excuse me, yeah. So a 120 litre would happily deal with, say, two or three people at a push. Okay.
Okay, one more question from Richard about solar thermal. Richard, if you'd like to unmute and ask your question.
Oh, hi. I'm actually Anne. It's all right. I'm trying to start the video. We've got solar thermal panels. Could you just wanted to check, can this be connected up to solar thermal panels?
Yes, absolutely. I mean, in fact, solar thermal is the only technology that we need to know sort of up front, and you need to make the decision about before you buy the cylinder, because we need a bespoke coil in the cylinder. It's a slightly bigger coil, bigger surface area. We put it at the top of the tank. So, you know, we just need to know what else you need to connect it to. So if you're running a gas boiler as well, we put a twin coil in for both those indirect sources. Okay. So yeah, that is absolutely feasible. We just need to know up front.
Okay, great. Thank you.
Yeah, I just have a quick question myself, actually, James. It's a use case, really. I'd like to understand how you control the system. You know, for example, my children are off at university. When they come back, how do I set the system? How do I know how to set up the system for when they come back to make sure they're not having, or rather, we're not having cold showers?
Yeah, absolutely. So, I mean, you're going to be using more hot water, so you just need to make that adjustment yourself. It depends on whether you can do it either in the schedule. So your upcoming dates, you can change the volume of water that's actually heated. So you can say to it, look, perhaps, just you're using maybe 20 or 30% of the cylinder before they come home, and then you might want to increase that to say 60% as a minimum, when they're back for the weekend or whatever it might be. Okay. Certainly if you're on the machine learning where it's predicting how much hot water it's expecting you to use a certain amount, so that needs to really be sort of taken off and go into your manual schedule basically, and just increase. Or you can just keep everything the same and just manually boost when they actually need water. It's as simple as that, because we're getting there 5 times quicker, and it's still twice as quick on gas. You could just literally just use the manual gauge on the side of the cylinder and just manually boost it as and when you go.
Okay, and we've got one more question from Dave about dealing with hard water.
Yes, we live in a very hard water area. So how does the tank handle it, or the coils?
Yeah, so we've taken a couple of precautions. We have got sort of metal parts heating up in water, which is always the issue, really. So anything above sort of 300 parts per million poses a bit of an issue, and a warranty issue as well. So it's always good to sort of check that out with your water board. And it just needs to be treated in the same way as any other standard cylinder. So the installer needs to, if it is particularly hard, then they need to put water softeners in, however they deem, the best technology to incorporate. The steps that we've taken is the fact that we don't have as many metal parts floating around in warm water, which is where you're going to attract that sodium carbonate buildup. The actual plate diffuser at the bottom of the tank sits in cold water, because we're taking the cold from the bottom to the top of the tank. So it's not sitting in hot water, the main plate diffuser. We also have titanium coated top immersion as well, which detracts from that scenario. So as I said, just take some advice from whoever you get to install it, if you install it.
Okay, I think we'll draw a veil on the questions now. And thank you very much, James, for a fascinating insight into how the tank works and the technology and what it's capable of. It's amazing stuff. And we'll swiftly move on to hear from Leigh Fairbrother from Qbot, who quite a different technology area. He's going to talk to us about their system for robotically spraying insulation onto suspended floors. Thank you very much, Leigh.
Thank you, Chris. Thank you. Thanks for the invite and for the opportunity to speak to everybody, and for your time this evening. Hopefully you can all see the Qbot logo on your screen. Get a nod? Yes, fabulous, good. So like many of you, I've been looking at retrofitting properties for a long time, not least this one, but I have a background which started studying architecture. I'd worked in a number of different industries before working on big solar PV projects with social housing providers about 10 years ago, and that led to an introduction to energy efficiency and fuel poverty, which sort of shaped a number of companies that I was involved with. And I joined Qbot about 18 months ago. And one of the reasons I joined them we do a lot of work with social housing. And over the last number of years, I've been to countless exhibitions and conferences, and in that time I've seen lots of technologies like Mixergy, which I've been watching for a while, things like smart Internet of Things controls, and I came across Qbot about 3 years ago, and every time now and then you see a technology you think will really make a difference. So when the opportunity came up to join them about 18 months ago, I couldn't say no. So you can see on the screen there one of our latest generation of robots. This is the Mark 7. Our goal is to make it easier for contractors, homeowners, housing providers to inspect, maintain and upgrade buildings and develop quality retrofit. Certainly in the construction industry, we're using centuries-old techniques in many cases. So we are a technology company that employs robotics, 3D scanning, digital tools, artificial intelligence. We also have machine learning algorithms to identify the needs of properties, to automate repetitive tasks to make it cheaper and easier to retrofit them, use technologies like robotics to reach the parts that we couldn't otherwise reach, and then track all of that and share that data seamlessly, which is incredibly important both for quality assurance, but also for funding mechanisms as well. So we're talking today about our robotics platform, but in bringing Betty, as we affectionately know her, to market over the last 8 or 9 years, we've actually developed 3 distinct platforms so far. We have a digital twin platform, which uses scanning technology to create 3D representations of properties, so it's easier and quicker to design retrofit in solutions for them, reducing the overall cost, because as some of you may know, it's quite expensive process. We've developed the robotics platform, of which the underfloor robot is the most commercially recognized. There are more robots in development, and you'll see those introduced over the coming years that address different problems in the built environment and different parts of the retrofit journey. And then we have a software platform that stitches all of that together and means that the work can be traced and audited very easily. And all of those can be used together or individually. So when the company was founded in 2012, our founders, which is an engineer, an architect and senior lecturer at UCL, identified floors as being a problem that needed to be addressed. Roughly 1 in 3 homes in the UK, over 8 million, have suspended timber floors, and currently less than 1% of them are insulated. And unless we find or have found a way to resolve that, we won't be able to hit our carbon reduction targets. Typically, we lose about 20% of heat loss through an uninsulated floor because that's the way it was designed. Typically older properties that have chimneys and fireplaces, you needed a mechanism to draw in air from the outside that was then taken up through the floor to fuel fires and provide air for them. We've replaced most of those fires with modern central heating. So those mechanisms aren't really needed, but the air vents and the suspended floors remain, and that causes a lot of drafts, about 1/3 of uncontrolled air infiltration, and that also brings in cold, damp, moist air into our properties, which obviously takes more to heat and causes damp and condensation problems. Traditional methods to insulate floors are disruptive and messy. Traditionally, you would need to remove all the furniture and fittings, lift the floor, and then install either an extruded foam or a mineral wool equivalent. As you can see, it makes a bit of a mess. Therefore, it's put people off, and it's not been addressed particularly for a number of years. Unless you get that seal exactly correct, you're going to have air gaps, and that's where you can trap moisture and cause damp problems, or you can reduce air. You don't reduce the air infiltration, and therefore you've still got cold, moist air coming into the property. So it's expensive, it's time consuming, and it's hugely disruptive, which has meant it's not very popular. Qbot has developed a robot, or a series of robots, that fit neatly under the floor into the void space. And they can install a typical property in as little as 1 to 3 days. Generally, for a private homeowner market, the average install cost is around just over £3,500, or just over £3,000. And that typically represents a cost per sat point improvement, for those of you familiar with EPCs, of about £500 to £600. It's an incredibly cost-effective way to improve the energy efficiency performance of your property. And if you're renting a property, then that is important because you have to meet certain standards in order to do that. And obviously from a comfort perspective, it's incredibly important. It also means that we are an eligible primary measure on the Green Home Grant Scheme and similar schemes which are funded for local authorities, and anything that comes out in the future will be very similar. The high performance foam that we apply reduces the risk of damp and mold by creating a seal to the floor to reduce that air infiltration and creates a hydrophobic barrier protecting the underside of the floor from the moist ground below. If you have the time, I'd recommend you visit the website. You can go on to what we call our eligibility checker, and you can enter some details about your property type and age, and it will give you an indicative guide to the cost of install and some of the characteristics that we look at when we're doing surveys. So if it is something you're looking to inquire about, then you can go onto the website, you can complete that. There'll be a link that will allow you to go through, and if you want to book a survey to do that. At survey, we typically create one access point at a property. It's usually 100 by 200 mil wide, which is smaller than this diagram. And what we're doing there is we're looking to ascertain the health of the floor and the space underneath it. Most people haven't looked under their floor in a very long time. Why would you? So we're looking for a void height. That's the depth between the bottom of the floor joists and the ground underneath. We want to ensure that's at least 200 mil. That's because there's building regulations that say you can't insulate below 150 mil, which is unfortunately what I have here in this suspended floor. And we're looking for the health, and we're checking moisture content levels to ensure they're below 20%. The floor's healthy. We're also looking for things like wet rot, dry rot, infestation, or woodworm that might have prevent install because the floor is not in a condition and remedial action might be required. We'll look at the practical considerations. We'll look at the ventilation in the property, because installing insulation like this and reducing air infiltration means that there may be a requirement to replace some of that with controlled ventilation to meet building regulations. And that provides us with all the necessary information to be able to provide an accurate quote. We work with social housing providers as well as private homeowners and local authorities. And when we're given the go-ahead to do an install, we'll deploy an install team, which typically is one van, one robot, and 2 operatives. They'll set up a control station outside of the property. Whilst the install takes place, you can remain inside the property as long as you're not in the room directly above that that's being insulated. So as you can see in the diagram here, the family are on the upper floor. Our installers would come up with an install plan for your specific needs around your access that's needed at times and areas in your property. And then the robot is controlled using a gamepad on the control station from outside. We'll create a slightly bigger access hatch, which is typically 300 by 400 mil, to put the robot under the floor. The robots are incredibly sophisticated and robust, very powerful, a lot of traction so that they can operate in the underfloor environment, potentially pushing rubble around and in some cases making holes in dwarf walls to be able to maneuver. They're fitted with visual cameras as well as LiDAR, which allows them to create a 3D point cloud map of the underfloor environment so we can identify risks. And so that we can verify the work that we're doing by accurately measuring the depth of this insulation we put in. Once the operator's been around under the floor with the robot and we confirm that we're able to begin, we'll start to apply the foam in layers, applying a very thin layer first of all, which acts as a seal, stops any foam from expanding through the floor joists, and then we'll build up those layers to the depth, typically about 125 mil. For those of you interested in its performance, it provides a performance, a U value of about 0.19 to 0.2. So performing more than the building regulations require and significantly reducing the demand for heat. And then the robot then uses the LiDAR to then verify that by scanning the depth of the insulation so we can calculate that U value. As I say, all of that's controlled from outside. You can see that, therefore, if you're being installed, you can obviously look over the shoulder of the installer and see what's happening, see the view that they have from the robot underneath the floor. And the robot also captures video and images, which are then stored on the install system so that they can be used for auditing and verification processes. At the end of this install, I say typically 1 to 3 days, depending on the size of the property. We can spray anything up to about 50 square meters in a day on a typical property, which might require a couple of access points. We'll do final checks and get sign off from the customer. And then we'll follow that up later with surveys with you to see how it's performed through its first winter and the impact that you've seen. What you have here is a typical uninsulated suspended timber floor. You've got cold, moist air coming in through the outside, through the air brick. Negative pressure through opening windows or chimneys will draw that up through your floor, and that deposits cold, moist air on the surfaces in your property, which obviously, because they'll be centrally heated, in most cases will be warm, so that causes condensation and damp. The hydrophobic barrier that the robot creates a seal, which reduces by up to a third the air infiltration in a property. We encase the bottom of the joists to reduce thermal bridging, but you'll notice on this diagram where it's a solid wall construction, we've tapered the insulation to the edge there, and that means that if there's any interstitial condensation, any moisture transferred through the wall to the joist ends, it has space to naturally wick away with the underfloor ventilation. What you have as a result then is more evenly distributed temperature throughout the property. You have reduced the drafts by roughly a third, and that will have an impact on reducing energy bill on average by about £150 per year. So it's more comfortable, you have warm feet, and you've significantly reduced the demand for energy and heat. And that translates roughly to, on average, about 600 kilogram of CO2 equivalent a year. The embedded carbon in installing Qbot, which takes into account the carbon in the material, as well as the process of manufacturing the robots, which we do in the UK, transportation to site, the fuel and the energy that's used to install, typically takes about 800 kilograms of embedded CO2 equivalent. So effectively, after install, it's usually carbon neutral in less than 2 years. And over its expected lifetime, which is currently about 42 years, based on the fact that this foam hasn't been around for any longer than that, you're looking at saving roughly 25 tons of CO2 equivalent through its lifetime. All of that is logged and recorded both before and after photos on our IMS system for verification. And with our clients, they have, with our social housing clients, they have dashboards so they can access all of that information. Bear with me a moment. It just slows down at this slide every single time. Just take a second. There we go. For those of you familiar, we are an eligible Eco3 innovation measure, which means for low-income families, there is potentially support from energy company obligation contributions. And that can range anything from 20 to 75%, depending on the type of property and the area that's sprayed. As I mentioned, for the government schemes as well, there's also been for the Green Home Grant Voucher Scheme between 67 or 2/3 and 100% funding. From an impact perspective as well, we get a very high referral rate from both our private homeowner customers, which make up about 1/4 of our business, as well as from our social housing providers. And there's some Google reviews and Trustpilot reviews there, which you can obviously check out on our website or theirs. And importantly, the end users find the benefits are pretty much immediate, especially in terms of reducing drafts and increasing the thermal comfort in the property. We know that there is no other technology that we're competing with for flooring, but nothing else can get into the floor voids that we can operate in. And therefore, we appreciate that most people are looking at which measures to do on their homes to retrofit them to have the biggest improvement. From a SAP improvement score, so from your EPC rating, once you've done 270 mil or more loft insulation, then the most cost-effective next step is to insulate your floor. External and internal wall will have really big impacts on properties, but they're very expensive to do. The energy savings you'll make through putting in floor insulation are significant. They won't be things like external and internal wall will save you more money, but it will be at a much higher capital cost, typically somewhere in the region of £10,000 plus for external wall, especially if it's compliant with the latest regulations. And therefore your payback period compared to other measures that you might want to install on your property or a suite of measures is much quicker than the others. I think got some FAQs at the end, and I know that I've shared this in PDF format so that you can all have a copy. But I'm more happy to take any questions that you might have.
Yeah, I'll send a link to the presentation shortly, Leigh.
No problem.
We've got a few questions. Question from Sean, I think partly about ventilation, but specifically about wood stoves. If you would like to ask your question, Sean.
Yeah, thanks. Yeah, so you said you've got to stop all the ventilation, all the gaps and air gaps and so on. So does that mean you can't have a wood fire stove?
No, not at all. So a wood fire stove should, by current building standards, have its own dedicated ventilation. So depending on when it was installed, that was probably as part of its install, so it will have its own dedicated air supply. If not, then when we were installing, we would install a dedicated floor or wall vent to ensure that it was compliant.
Okay, thanks.
No problem.
And the next question is from Anne, if you'd like to ask your question, Anne.
We've got an Edwardian house and the void is about 40-50 millimeters, and having done several different ways of doing some of the rooms underfloor, I'm keen to find something like this. But it's littered with debris from bits of plumbers, old water pipes, bits of cable, rocks, God knows what's down there.
Yeah.
I mean, it's clearly not, I can see it's got chunky tires on, but it's obviously not that heavy. I mean, does it get,
it's surprising,
bit clear, or does it get tangled up, or?
It's surprisingly heavy to give it the traction. Each wheel is an independent electric motor. Obviously, it's been designed to work in these environments and to drag the tether, which supplies the insulation foam. So the vans that we use are typically about 3.5 tons. And if you put 2 robots in front of it, you can drag the 3.5 ton van. They're incredibly powerful. So I think it's a 40 to 50 centimeter void.
Yeah. Oh yeah.
So I thought, that we'd be able to use one of the larger robots for that. They are there. They have suspension. They're able to move over more uneven terrain, and they can also push through sleeper dwarf walls in order to gain access. So they can create small access points for themselves once they're in the floor, or our installers can do that. So it would involve a survey, and the surveyor would make an assessment of whether it be suitable or not. But if you've got a sort of 400 to 500 mil void, I would expect that they'd be able to make it either by creating more access points or by using the robot to go over some of that rubble.
And I mean, it doesn't get sort of tangled up in wires.
And that is the kind of key skill for the operators, is understanding spatially where the robot is under the floor. And obviously it's got cameras on it, and it's got a turret you can move around, front and back cameras. It's the skill of understanding where it is, where it's going, so that you can maneuver it without getting tangled up. But they're very, very accomplished at sort of, you kind of lay the cable along the side and then move up and down. I've got a little bit of video footage I can show it if we've got time to give you.
And you can push through sleeper walls without making the house fall down.
Yes. Well, sleeper walls are only there to support the floor. They're typically honeycomb anyway for ventilation, so you can take out a small area without compromising the structure.
Okay, thanks. Interesting.
No problem.
Next question is from Margaret. If you'd like to go ahead and ask your question, Margaret.
You might still be on mute, Margaret.
Okay, I just was wondering if people have to be out of the room when you're doing the work, and then you do all these checks and things. How long would you estimate they would have when you finish before they could get back does it have to cure and kind of ventilate for a bit?
So we attach extract ventilation to the floor vents whilst we're doing it. We say for safety purposes that it's about an hour after install. We would recommend leaving the room, but the foam cures after about 60 seconds, at which point it's benign. So there's very, very low risk, but for safety purposes, we would give it an hour to be safe.
Yeah. So that's great. So you would work during the day, and by the end of the day, they'd be able to get back into the rooms.
Oh yeah, absolutely. Yeah. And if it was a multi-day install, because it was a large property, then they would they'd leave the property as was and come back the next day to continue.
Thank you.
No problem.
And we have a couple of questions from Richard Robertson's account. Sorry, I've forgotten what your name was.
I think it was Anne, was it?
Yeah,
go ahead.
Yeah, I'd just like to ask about the polyurethane itself.
Mm-hmm.
Is it, inflammable or flammable, in terms of safety?
It has a fire rating of class 1, which means that it meets all of the necessary building regulations for us to have a BBA certificate and comply. The foam itself is not the innovation, it's the delivery system. So the PU foam that we use is a BASF product currently, and that has been installed in properties for nearly 40 years, and it's in millions of homes across the UK in different formats.
Okay, and the other question was about dealing with pipes. If there are heating pipes under the floor, how are they dealt with?
So the mobility of the robot and the turret and the skill of the operator means that we can maneuver around and spray around items with a high level of accuracy. We don't insulate services, so we don't insulate electric and gas, but if there are water pipes there, they can be insulated and encapsulated, and that's no problem, and that will obviously prevent heat loss.
Yeah, thank you.
Similar with if you were having, if you were looking at having solar thermal on your roof, you would make sure that you didn't need to re-roof in the next 10 to 15 years. So the recommendation would be, if you are looking at changing your heating system altogether, either that it would be surface mounted, or you'd do that work before the install, so it didn't have any impact.
Right. Okay.
I can just.
Yeah, that's all the questions, Leigh, if you'd like to play the video.
Yeah, so this is the latest generation of robot. That's the screen that the operator will see. So it allows them to target the area they want to spray, and then they'll start to spray in layers and then back up, and that foam will then start to expand. And they basically do that runs along the underfloor environment between the joists, and you'll be able to see it will cut back in a moment to the view from the operator. So you get this kind of targeting system, which makes it easier for them to control. And if I skip ahead a little bit, they'll turn the robot around in a moment, and you'll be able to see what that looks like from the front. Here we go. So because all the full tires work independently as motors, you can turn it over on the spot. This is our test facility in our lab in Wandsworth. And you'll be able to see here the spray gun at the front. So hopefully that brings Betty to life a little bit more.
Thank you very much, Leigh. That's, well, 2 fascinating talks, actually, from and a lot to think about. Obviously, it's not just heat pumps and PV cells, is it? There's an innovation in all aspects of home energy efficiency. So great presentations, and thanks very much. And those been posted, Paul's just posted them onto the chat. I've got a couple of asks before we wrap up for the evening. First of all, if it's at all possible for James and Leigh to stay with us for a couple of minutes. If there are any further questions, we'd really appreciate that. But if not, if you haven't got the time, then I'm hopefully going to be sharing my final slides, which are obviously it would be very helpful for people who've attended the call if they could quickly give us some feedback using the link that's going to be in the chat or is on the screen now. It gives us an idea what what we can do to improve in the future, and it'd be very much appreciated if we could get some feedback. And likewise, another request is Cambridge Carbon Footprint, who of which Open Eco Homes is a part, is a charity. And if you have the means and the inclination to do so, we very much appreciate, let's say, a £5 donation to Cambridge Carbon Footprint to help us with the the work that we're doing to enable people to see how to improve their homes' energy efficiency and ultimately reach net zero. And to plug Open Eco Homes resources in particular, we still have availability on the tours that are yet to take place. So you can find those on our website and book them on Eventbrite. There's a thermal imaging camera which is available for loan and training on that, and I hope that that's going to be available for loaning out so people can use it soon. And then there are obviously resources on the website, particularly if you're getting started with your retrofit. Check out the Get Started with Your Retrofit area, because that will enable you to get going on what is, I can speak from experience, is a daunting journey to get moving with. So again, I just want to thank James and Leigh for their time and effort and some really interesting presentations, which I'm hoping we all found interesting and useful. So thank you very much for your time. Now, if you're willing to stay on for a few minutes, James and Leigh, we can see if there are any further questions. But if people want to leave now, that will be absolutely fine too.
Yeah, happy to answer any more questions.
Yeah, likewise, guys. Don't be shy.
I've got a question for you, James. I was saying earlier, I want to install a Mixergy tank just in there, and I'm putting thermal. I've got permission to put thermal on the roof. I want to use PVT. So I take it there's no challenge in connecting it to thermal, PV, and a gas boiler.
No, it's absolutely fine. Yeah. I mean, it's more and more of what we're doing. We're talking to a company called Naked Energy at the moment, if you know those guys. So yeah, we're trying to sort of liaise with those guys on a few commercial projects at the moment. So yeah, absolutely, that's no problem.
Sure.
I think there's another question from Anne, actually, if you'd like to ask your question.
Hi, James.
Hi, Anne.
It's really, we've got a combi. And obviously it doesn't have a tank, but if in future, and at some stage it will die, and if in future we have a heat pump, clearly we'll need a tank, domestic hot water tank. So can we actually use your system at the moment with the combi and be using off-peak low carbon electricity overnight, and then when we needed it, use the combi, so kind of mix and match it, or is that not?
No, I mean, we've taken care of the hot water side of things for you. The only other thing, is how you're going to power, how you're going to heat that water up. So as I said in the presentation, we facilitated that change to anything that you might want to do in the future. So we launched in February this year the heat pump ready range of cylinders. So it doesn't matter what you order now, even if it's simple 120 litre direct electric, for example, or indirect. I mean, all indirect cylinders have the top immersion. So all cylinders come heat pump ready, and they all come with that facility to tap in and out of the grid should you need it. Now you may want to even swap. I mean, there's a dual fuel AI system on board, which will basically analyze what's cheaper at certain times of day to heat your water with. Is it going to be grid electric, or is it going to be gas? Now, sometimes with Octopus Agile tariff, that tariff can fluctuate from between anything from 25 pence per kilowatt hour, which nobody really wants to pay for electricity, to them actually paying you money to use it. So when the network is flooded with renewable power, aggregators like Octopus, jump on this bandwagon, and they become brokers for energy. I mean, effectively, that's what they are. So the system will analyze, based on your schedule, what's the cheapest way to heat that water at a given moment. So it will flick automatically between gas and electric if you choose that setting, for example. And on the heat pump side of things, all you need to do is employ the services of we call it an LTPHE, which is a low temp plate heat exchanger, basically. So with standard heat pump cylinders, what you find is there's a big 3-meter coil within the cylinder. And it's a very simple upgrade to a Mixergy in that we've just taken out that 3-meter coil. That 3-meter coil takes up a lot of the volume of the water. So with Mixergy cylinders, you actually get 20% more hot water from the same size cylinder. So the installers that we work with at the moment are constantly having to oversize the cylinder. So say, for example, you needed a 210 litre, they would insist that you have a 250 because they know that the volume is taken up by this big 3-meter coil inside. So we don't use that. We have our plate heat exchanger, which fits on the side of the cylinder. So if you were to connect a heat pump straight away, then the cylinder would come with that on the side. And you'd obviously have to pay the extra for that. And if you want to do it in 6 months' time or 5 years' time, then absolutely no problem at all. The porthole spacings are ready to accept that piece of kit. Okay, so yeah, I mean the internal stuff is all taken care of. You just need to include that technology.
And it's no problem using with a combi, even though obviously one doesn't normally traditionally use a combi with a hot water tank.
No, absolutely not. I mean, it's quite commonplace to turn a combi into a system boiler anyway. So yeah, there's no problem with that. Yeah, I mean, it's a usual 2-port valve scenario, 2 or 3-port valve scenario. There's no difference. Yeah.
Hi,
Margaret.
I think Margaret, you'd like to ask a question. She's just unmuting.
There it goes. Okay. I'm in the opposite situation where we got a heat pump, but we really didn't want to completely reorganize our hot water system because it's linked to an airing cupboard. But eventually we will want to replace that. So we could get a Mixergy tank that would give us probably more capacity, ready for a heat pump and for solar panels.
Absolutely, yeah. Yeah, indeed. So with solar PV connection, if I deal with that first, all you would need to do is go with a third-party PV controller, a diverter control unit. Yeah, absolutely. So all that needs is linking in via a 3-core flex, which is a pretty simple job for Sparks, into the top immersion, and away you go, basically. Okay. And in terms of the heat pump side of things, I mean, you can actually run your your loop temperature from your heat pump to the cylinder at a slightly lower temperature, which gives it a bit more, it elongates the life of the heat pump. Basically, it's working less hard over time. You get a nice even heating with the way that our heat pump cylinders work. If you imagine a plate heat exchanger that fits onto the sort of bottom side of the cylinder, it then loops right into the bottom. So you're heating from convection directly from the base of the cylinder, so you get a nice even heating throughout the cylinder, as opposed to a standard 3-meter coil inside a cylinder. It's okay when the fluid enters the top third of the coil, you get a nice heat transfer, but as it passes its way down through the bottom third of that cylinder, the coil rather, you get less of a heat transfer. So not only is the 3-meter coil taking up the cylinder volume, you're also getting a lower heat transfer from the bottom third of that coil. So again, it's at the detriment of the amount of hot water you're getting from that cylinder. So yeah, absolutely. I mean, 20% more hot water, and you also get that the flexibility of not asking your heat pump to. I mean, if you want to take an impromptu shower or bath in the afternoon, and say you've set up your heat pump to heat your water overnight on a cheaper tariff, for example, if you're short on hot water and you're going to need only enough for a short shower or something like that, you can just go onto your app, flick it into direct mode, and then just volumetrically heat, say 20%. So you're not asking the heat pump to fire up, get up to loop temperature, and then start transferring the heat to the cylinder and heat the whole cylinder. It just gives you another piece of flexibility, basically.
We we have only a 210 liter, but the house is big enough that the RHI wanted it to be 300 liter, and we couldn't fit that under the slope of the roof, so we just did without a new cylinder, which is a pity. But for two of us, it didn't make sense to put in an enormous new.
No, it doesn't make a lot of sense, to be honest. The same with MCS. You know, it's crazy really that you go on sort of size of property as opposed to actual use in the property. I guess it's just going on potential use rather than, you know, the actual specific scenario that we might be looking at. But you know, with the 210 Mixergy, at least you know that you're going to get the same performance as a 250 or possibly even a 300 standard cylinder.
I tried that for the RHI, but they said no.
Yeah,
it had to be 310, 300.
Yeah.
And
yeah, indeed. Yeah, so we spend a lot of time at the moment trying to sort of alter legislation, and we've just been accepted on the Appendix Q in terms of the volumetric heating capability of the cylinder. So it's a constant thorn in our paw. We're sort of ahead of the curve and trying to you know, pronounce ourselves as widely as possible.
Do you have any idea what's coming in March after the renewable heat incentive stops?
I don't actually. I'm not too au fait on it all, but time will tell, I guess.
We're waiting for the report, but I just thought you might have been anticipating that. Okay, thank you very much.
Thanks, Margaret.
I'll ask a quick question of Leigh. You mentioned in passing the, I guess, digital twin would be a way of looking at it, or that you produce. Is that a service that you run or provide, shall we say?
It is, yeah. Basically, when we first introduced, we knew that we had to have a really robust quality assurance process because people were not going to see the majority of work we ever did, and therefore we equipped the robots with LiDAR and visual cameras. And when our clients saw what they could do, they said that information would be really helpful above the floor. As some of you may be familiar, designing an individual retrofit plan for a house is actually quite expensive, typically about £3,000 to £5,000. And if we extrapolate that across all the 29 million plus homes in the UK, it's just not feasible. So we need systems in order to be able to make that cheaper and faster. So we developed a scanner that combines LiDAR with visual and thermal capabilities, overlays them, and then creates this 3D model. And we, predominantly we do work with social housing providers, but earlier this year, one of the clients of a social housing provider wanted it on their own home. So we did it for their own home. They gave it to their architect to help the design. The architect goes, "This is amazing. I want it on all of my the projects I'm on." And so then we've started to do it for individual homeowners as well. So I can show you, this is a very large property. I pulled this one out just because it's particularly impressive. But I can show you an example of what that looks like. So this has also got the grounds as well. And you can obviously see the representation from outside. We've capture information on sort of stock condition survey information, which is then annotated to the individual elements. And that may include photos, which just takes a bit of time to load up while I'm doing this. But more importantly, architects can use this. They can download the 3D model, they can interrogate it, they can take off any measurement, they can then go into any property in any room. You can then look at the individual elements within there. And if it was loading a bit faster, you would be able to see, I can click on an element, look at the photos, look at a 3D panoramic, and basically swoop around and look at the overlaid thermal imagery as well. So you can identify, is there any cold bridging in this particular space, in this particular room? And yeah, so you can kind of walk around it in chop it up in a number of different ways to see within different spaces and what you might want to do within there. So particularly useful for architects when they're doing this whole house retrofit approach. And the longer term goal of this, because we do a lot of work with Bays and with Innovate UK on developing different technologies, is that you'll be able to do this, and rather than have 20 different contractors come to your property to view it, which is what I've had recently, you'll be able to give them access to this. They'll have all the information they need to be able to quote. And the next stage after that is to then build that into the model. So you'll be able to say, ask the model to be able to say, right, you can fit these measures based on the accurate measurements we've been able to get from doing this scan. This is the cost of doing this measure. This is the cost of doing that measure. This is the expected improvement of performance. So we're still on that journey that, it does the first couple of stages. It hasn't reached its full potential yet, where we'll be able to do all of it, but that's the kind of the direction of travel for the tech.
Wow. Okay.
Just one more question from Anne, I think.
Go ahead.
Sorry, yet another question. This one's for James. How much of the heat? What's the heat loss like per day, particularly if it's only half filled with hot water? So you must have some sort of conduction within the tank from hot to cold, or does that not count? But anyhow, what's the heat loss per day?
Yeah, so the heat losses are we have to basically clarify heat losses in terms of the whole cylinder being heated, basically. And then on our spec sheet, we produce another figure, which is basically half that value, which you can use in terms of like SAP protocol. So yeah, so I mean, I can send you over the data sheet, Anne, if you'd like, and you can have a good look at the heat losses for the various tanks.
Okay, I think that's probably all the questions from what I can see. Has anybody else got anything they would like to? Oh, yeah. Anne has asked another. Anne Rivington.
Yeah, I just wondered, how much it would cost for, I've got a 4-bedroom 1930s semi-detached house to have that kind of the digital twin assessment that you were just talking about, to have that plan.
So need to have a look at the plans of the property to give you an exact quote, but probably in the region of about £1,100 to £1,600.
Right. Okay. Yeah.
And then, and obviously, then you get the full access to it and the training on how to use the system.
Right.
I as a comparison, when I needed a survey for this place.
Yeah,
sort of similar size, four-bedroom house. This is slightly older. I live in Bath. This is 200 odd years old.
yeah.
And I used a surveyor to do the study to basically capture the information that was in that drawing, but just in 2D format. And it is a very similar kind of cost, but all you get from that is a few drawings, sections and elevations and plans, whereas with this, you get all of that plus the 3D model, which really kind of brings it to life, especially from the architect's perspective.
But it would give you suggestions of saying, well, these are the key areas,
Not at this stage, no.
Not that's a future stage.
Yeah,
okay.
Yeah. That's what the architect's role currently, and we work with the architects to identify that.
To look at that. Okay, thank you very much.
No problem.
Great. Thank you.
And I think that's probably time to wrap it up then. I can't see any more questions. Thanks very much, James and Leigh, for taking the time. It's fantastic. And I think we're all a little bit shell-shocked and blown away by what's possible. So